Hello, everybody. I hope you're all enjoying the Berlin buzzwords, and this is the last session. I'll try to be quick. I'm Dhrubo Saha, and I work in OpenSearch, mostly in the machine learning space. And today I'm be talking about the advancing multimodal search capabilities in the search pipeline for OpenSearch. So let's start. We already know about mostly what OpenSearch is, but I just want to again start with what is OpenSearch. At its heart, it's mostly the distributed search engine and the analytics engine. And the distributed is the main part, key part here, because it's designed to operate seamlessly across multiple machines. And it's also fully open source under Apache 2.0 license. And it forked from the Elasticsearch, but after that, OpenSearch already evolved a lot with its own vibrant ecosystem. So that's the part we are super excited about. And these are the main basic capabilities of the OpenSearch, which is right now, with growing the ML capabilities, right now we can do the vector search, similarity matching, and with the KNN with multiple algorithms. And hybrid search, because semantic search also falls short at some point. So we need to combine the lexical search and also the neural search, so that we can combine between these two to make the better search results. And we also have the traditional search and analytics, visualizations, and security monitoring, which mostly we talked in other talks as well, our other members. And here I want to talk about mostly what are the machine learning features we are developing in OpenSearch, which is my team, ML Commons, OpenSearch ML. This is a plugin. And this is the main machine learning framework in OpenSearch. And here we have built the unified system for the ML operations. This framework is what enables all the sophisticated ML features, which we will be discussing today, including my multimodal search. Cool. Now, this in ML Commons, what we do, we have the model management. Model management means like here we can support multiple different kind of models, which is local model. Local model is kind of, before coming the LLM, we were also supporting the sentence embedding model, which generates the embedding and we can ingest. These are the local model. We already have a pre-trained model list. From there, customer can choose whatever the model, what dimension they can choose, and they can register in the OpenSearch to generate the vectors. And then right now, we also have the remote model. Remote model is kind of like we are making a connections between your LLM service or any other model. Like let's say you host your model in your own service. So we have the connectors so that you can connect with the model through the remote model. And then this is the custom. You can also train your own model, a small model, not to go to the LLM, and train your own model and bring your own model in the OpenSearch. And then right now we also develop the agents. There are multiple agents. Right now, this is the agent is high topic. So we have flow agent, conversational agent, and then recently we also published plan, execute, and reflect. So I will talk about a little bit more agents later after showing the demo and also the future goal of us. But mostly flow is kind of like, okay, we have a lot of tools. So we get the outputs from one tool and then we forward that output to the another tool so that the flow can continues in the agent and we get the responses. And then plan and execute and reflect is most likely like you can talk with the LLM to make a plan like, okay, how you want to have the search. And then based on that, agent execute that search. And then after that, agent also thinks that, okay, is that the plan? Am I going forward with the plan? And based on that, it also reflects. And finally, the ML inference processors, what is the main topic for today, including the multimodal. I will talk more details in the ML inference processor lately. So these are the agenda, mostly after giving the high-level overview of our team and OpenSearch, why we need the multimodal search. And also we'll discuss about the ML inference processor, deep dive in the 3 different parts of the ML inference processors, and I'll show the live demo and also the future goal, what we are going to show. Okay, so now the question is like, why do we need multimodal search? We know that how exactly the search started getting evolved. Before we had the traditional keyword-based search, this doesn't work that much. So we have to make the semantic-based search. But again, semantic-based search also falls short. So we want to combine between these two as a hybrid search. And after hybrid search, well, we have a lot of images these days. We have a lot of audios. We have a lot of videos, and even in the PDF, we have table, graph. These are all different modalities. So how can we connect all the modalities and bring a bridge between together? So that's what comes the multimodal search, so that we can generate embeddings for different modalities, and then based on that, we can search. So now the basic question is, for example, imagine like, you have an e-commerce site and a customer looking for a chair, but he doesn't know the name of that chair, but he somehow get a picture of that chair from his friend's house and he wants to search that. And this, if the e-commerce search does not have this capability, so definitely he will not have the good customer experiences. And another situation we can talk about, like let's say a researcher was researching, analyzing thousands of hours of historical radio podcast or broadcast from the 1940s. They are looking for mentioning about a specific historical event, but the audio is not transcribed. So without multimodal search, the researcher needs to look for all the, listen to all the audios to find that. So these things we don't want. We want to have search better. So that's why we need the multimodal search. And we are incorporating this multimodal search in our ML inference processor. So the target of this ML inference processor is we wanted to have a more generic experiences. Like there are a lot of different, for example, if we connect with any kind of remote model, LLM service like Bedrock or Anthropic or OpenAI, every LLM has their different input-output format. So we don't want to have different experiences for different models. So that's why we wanted to feed all this in one simple umbrella, which is the ML inference processor. And in that ML inference processor, we have three different categorized processors, which is the ingest, and request and response processor, what I will deep dive a little bit more. For example, this is the ML inference ingest processor. Oh, by the way, I have all the QR code of my websites so that you guys can scan and then find more details of those processors, everything. So for example, this is one diagram, a simplest diagram, like you can have multiple modality, and these are the modalities source data you can ingest to the ML Commons, or aka OpenSearch. And inside OpenSearch, we have the ML connector, which is the model part. And this connector connect with any kind of embedding model. Let's say you have your local embedding model, or you can connect to the LLM. And then the ML inference ingest processor actually do all the heavy lifting, like it sends the data to the LLM and then generate the embeddings and then streamline the total process and then send that to the knowledge base of the KNN index. So this is the first data ingestion part. So now we ingested the data. So what happens in the search? So similarly, when any application is going to search a data, here what happens, like user make a query, and then the query goes to again the similar ML connector. And after going to that, we have the ML inference search request processor, which is kind of rewrite the query before going to the knowledge base. Because depending on some situations, you might need to get the mapping, different mapping. So those kind of mappings, all these rewrite things, we will do in the search request processor and send that to the KNN or the knowledge base, and then get the output and forward that to the applications. So this one is kind of more how we pre-process the search request. And now coming like, okay, I pre-process the search request. What about I don't want to show the same results from the LLM. We want to do some post-processing after getting the response. So this is the search response processor, which you can see that we get the response from there. And then ML inference search response processor, modify the response, and then send it back to the applications. So these are the three different components of the ML inference processor. If we try to combine all this together, this is what it looks like. For example, these are the different modalities. Ingest data source, you can have multiple custom model based on your requirement. You might have some parser. So for example, in the PDF, if you want to parse the data like table, all this text, you parse the data, and then through the ML connector, you connect to the either embedding model or the LLM model, and then this is the ingest pipeline, and then over there the search pipeline. And we also support multiple connectors. In the QR code, you will get all the list of our LLM connectors like OpenAI, and then also Cloudy, Anthropic, and then current booming is also DeepSeek. So all these connectors you can get there as well. Oh, cool. So I will show just one demo. So I'll show the demo from my, that's readable, right? Okay. I'll show a demo from my Jupyter notebook. To do that, I install some plugins, and then, okay. So in this demo, what I'm going to show like some e-commerce data, and I ingest the e-commerce data, and then I will try to search and show that how we can search based on the image and or even the text. And to do that, how exactly we are ingesting the data. So for example, to ingest the image, what we have to do, we convert the image to the base 64, and after converting the data to base 64, then we send that to the LLM to generate the embedding of the base 64 string of the image, and that's how you ingest the data of the image. Okay, now in this phase, I connected with the OpenSearch as a client. And now this is my product index of the vector search. And you can see that I have the ingest pipeline, what we were talking before. So this is the ingest, this is the body of the request body of the ingest pipeline. And then here you can see that we are providing a field informations. And this is the KNN vector index. We are defining a KNN index vector with 1024 dimension. And this is the KNN algorithm, HNSW, I'm just using as an example. And we can use any kind of dimensions depending on the model, what kind of model we are using backend. So now here you go, we create an index and also the pipeline. So now this is the pipeline informations, ML inference pipeline. So here before I already created the model. So you can see only the model ID. So that model is Amazon Bedrock Titan embedding model, which has also the 1024 embedding. That's why we see that dimension is 1024, because that's the 1024 dimension of embedding we are using here. Okay, we created the ingest pipeline. And then now we need the search pipeline. So in the search pipeline also similarly, we tried our best to keep the interface as same as possible for all the phases, like request, ingest pipeline, and also the search inference pipeline. So similarly, we are providing informations. These are all information we have, all the configuration values, whatever the configuration we need to use, all are presented in our website. I'm not going to deep dive super here. Just I'm mentioning that here I'm using the size 2 so that the result will show only 2 search results. And then these are all the mappings, what we use to get the search response. So now I created a ML inference search processors, right? So right now I have the KNN index, I have ML ingest pipeline, I have ML inference search pipeline. Now I have to ingest the product data. So this is the phase I ingest the product data. Right now it was around 2000 product data. So now here we can see that now we are going to search. So let's say I'm just searching men's watch black. Let's see what does it show. So we can see that it's showing the whatever we ingested the data is getting the right informations and is showing the black box. So these models are also multilingual. So for example, if I just convert the text query, which is Spanish, Relo Negro Masculino, and then it will also, I think it should show also similar kind of images. So it understands, although the overall ingestions happen in English and also the image, but it understands the query even in Spanish, and it also giving the results. Similarly, I can give another examples of the blue sneakers in English. So we can see that the data is coming with the blue sneakers. Although in the description, we did not have any information about like, and now if we convert that in another German language, so we still get similar kind of responses here. Okay, so now we ingested the data, we are searching by the key, by the text, but where is the multimodal? Like we want to search with the image as well, right? So I have some sample image. So I'm now searching with the image, not the text. So let's see how does that work. So you can see this is my black parse I was ingesting in the search. Like, okay, I want to see some search results of this image, and it was showing me the black parse. You can see the search results. And similarly, if I search with another red shoe, we can see that with the red shoes, it's showing that different images. And the interesting part is, like, for example, the style, it was picking and it was trying to find an image related to that. So that's the beauty of the multimodal search, which is the main presentations. And also, I will just go through fast. This is also another demonstrations of different data set with the real estate data. So in the real estate data, I'm just, let's say, I just search with the house by the oceans. So it was showing a house by the oceans based on the query, and then it understands the image. And so all the inference processor setup, everything was quite similar like before. So I'm not going through all this. I was just showing the results. And then similarly, when I was trying to use the image-based search, we can see that I was searching with this kind of image where we have a house by the side, and based on the data, LLM was trying to understand a house, and then it was showing some water with that. So that's the interesting part from the LLM. And also when we ingest the data, like converting the base 64 and then generate the embedding, the question sometimes may come that do we lose any image informations? But this is the example, like when we ingest the data, this is the original image, and we retrieve the from the OpenSearch, both are quite same. So we don't lose any kind of informations when we ingest the data and while we are retrieving the data. So these are the overall demo for our ML inference processors. And this ML inference processor can be also used as an RAG-based pipeline. So for example, I can give one quick example here. So RAG-based search means like where we use the agent. So we can have a conversational search, like I'm searching something and it didn't find. And so for example, I was asking like, hey, give some leather shoes for women. So it didn't find that. So I was like, no, I want black leather shoes. So it remembers the informations, then it was updating the search results based on that. So all these are coming. This was completely a conversational search, and conversational search is mostly coming from the agent. So agent is remembering the context of the previous conversation, and based on that, it forwards the conversation to the next iterations and then gets the inference. Cool. Now I will quickly talk about our future work. Yeah. So currently, I don't know how many you know about the MCP server, Model Context Protocol. So this is one of the booming thing, and we are also following the trend. And we also established our MCP server in OpenSearch. So these are the two blogs we recently posted, and we started seeing a lot of interactions from the community. So in the MCP OpenSearch, like you can connect with the MCP server, and you can get all the tools, whatever we have in the MCP server. Currently, we have 4 or 5 tools, but the beauty of that MCP server is right now we have a lot of APIs in our OpenSearch, right? So with using the OpenAI, with using the API specifications right now in the MCP server, what we are planning to do, we will expose all the APIs as a tool. So what happens that in the MCP server, we will have a lot of tools, and then this tool will be being used with the agentic AI, and then we will try to integrate that agentic AI with the ML inference processor. So for example, the setup I just showed, like there are a lot of configuration I was providing and then generating the setup pipeline. But in the long run, I want to tell the agent like, hey, OpenSearch, I want to create a ingest pipeline with this model and based on these settings. And it should create the complete search pipeline by itself rather than I need to do that. So that's the overall plan for us, and we are super excited on these developments. Cool. That comes to my presentations. Thank you, everybody, and you can connect with all of us. This QR code should have all the GitHub links, and also we are completely open source, and we have already more maintainers, and we are looking for maintainers to contribute and develop together. So feel free to check out, and then we will grow together.
Okay, thank you so much, Dhrubo, for that. Okay, so we do have time for some questions. Just raise your hand. Yeah, 1 second.
Thank you for the presentation. My question is, what was the model that you used to convert the base64 representation of the image in the latent space? Was a model that you trained yourself, or was a pre-trained model available from Amazon? Or
yeah, so in this demo, in this specific demo, I used the Amazon Bedrock Titan embedding model, which was already pre-trained model. I did not train or fine-tune that model. So you can use any kind of models, like you can use the DeepSeek, or you can use Cloud Anthropic, or even you can try to fine-tune your own model and then connect with that, and then similar way you can generate the embeddings and use the same. Right, thank you. Sure.
Okay. Next question. Yeah.
Thank you for the presentation. Can the ML processor be used asynchronously? For example, we have some use cases where the indexation needs to be performant. We need to be as fast as possible. Can we get the inference in an asynchronous manner, in the best effort manner?
Yeah, so this happens also asynchronously, and also in the long run, what we are planning to do the streaming as well. So that will be the development. We are also working on that, like asynchronous, and on top of that, we can also have the total streaming, so that prediction can happen in a streaming way, and the conversation, we can do all this in the streaming as well. Sure.
Thank you.
Thank you for your presentation. One question, maybe you explained it while you were showing the demo, but I didn't get, are you currently using KNN over multiple fields, or are you using a single vector in the index?
So there are two fields. One is the text field, which is generating the text embedding, and then another is the image, which is also image embedding. So there are two fields combined, and then that's what we can use.
And sorry, I have a follow-up question. Does OpenSearch give you a way to give different boostings to different parts of the KNN query?
Can you rephrase the question?
Can you give a different boosting to the image part with respect to the textual part of the query?
Yeah, you can do that too.
Okay. Okay, that was the question.
Yeah. Any other questions? Okay, so a big round of applause. Thank you so much.
Cool. Thank you, everybody.